give you guys round of updates of what has been happening from the 1st of April to 30th today. And apparently we're having good sun, as you can see. If you are aware of my distribution board here, I mean, if you've been following the series, I should say, I have three solar arrays. That is why I have three MPPT charge controllers. Here's one of them, about 1 kilowatt on that one. There is one here as well. Right there, you can see what I'm doing in real time on the top left corner. That's where the amp is, and on the bottom right corner, that's where you see the real time voltage. And on the bottom here, you can see the total that I've done today, 1,800 something watt hour. And you can see how many amps I'm pulling also in real time here. That's the voltage on the top left corner there. That's the voltage of the PV, the solar panel. I've got like 1.2 kilowatt there, and the amount of amps coming in, that's 28. And you can also see on this side, I think this is more in the real time. This is kind of in a delay mode. Anyway, this is the second chat controller, and the third one is actually here. I like visibility. That is why you can see watt meter on each of the chat controllers, so that I can see what I'm making in real time. I can easily detect what the problem is. Anyways, I used to use this particular chat controller, but I decided to upgrade to another one, which I'm going to be showing you. So I removed all the cables from the bottom of this, and now this is coming this way because I'm currently testing this other chat controller. I think I'm going to be having it right here on the table because I do not have enough space any longer. And this is my um, 6 kilowatt pure sine wave low frequency inverter. It's 6 kilowatt of it, and let's just take a look at each of these. One thing I like about this chat controller is the fact that it has its own watt meter, and I can see in real time what is happening in terms of wattage from the solar panel. I can see the amount of amps that are coming through. I can see the voltage of the battery, and I can see the PV voltage as well. And here is the total that I've done since I installed this particular chat controller, and this is what I have done today so far. And at the same time, I can keep track of what is coming from the solar panel in real time. The same thing with all the three chat controllers, basically. Um, Here's my energy meter. I've got this one for voltage protection and amp protection. I can set that to the way I prefer it. And over here is my energy meter. There are two rows on this interface, the top one and the bottom one. The bottom one gives me the kilowatt hour since I installed this module. The top one is actually in real time of what I've done up to date. I would normally reset it at the end of the month. So far this month I've made 180.5 kilowatt hour, and it's still running. We are still in the middle of the day. It's around 12, around 11:30 a.m. right now, half past 11. And let's go through the details. Right now, I'm doing 227 volts. You can also compare the data here. This is more in real time, but this is a little bit in delayed mode. And right now, making 6.6 amps. That's what I'm consuming in real time based on the load on this. And based on that, I have 1.4 kilowatt appliance on this right now. That is my frequency, and this is my power factor, which is quite good. That's because I've got a lot of loads on it right now. So another thing I want to share with you is this is 6.5 amps in terms of AC current, and this is 1.4 approximately in terms of the voltage of what I'm using right now, 1.4. What I want to share with you is based on this amount of voltage that I'm pulling, I want to see how much amps that I'm getting, I'm taking from the battery in real time, and I'm going to share that with you. So what I would normally do is this: I'll take my clock meter and I will change the clock to amp, as you can see, and I'm going to clamp it around the positive terminal to see how much amps I'm taking. Look at it, 55, 56, around that. That's what I'm putting right now from the battery. So there is no way you can compare that with the amount of amps that I'm pulling from here, because this is AC and this is what the kilowatts that I'm pulling, that is wattage, because it's reading wattage, that is 1400 approximately, that I'm pulling from here right now. So what you will normally do is you divide this 1.4, the 1400 watt, you divide it by your battery voltage, which is 24-volt system that I'm using, and that will give you approximately the amount of amps you'll be getting from your battery. Now, the reason why this is high now is because the inverter itself is consuming its own current, because I think on the standby it uses around 2.6 amps. So that needs to be added to the reading from the clamp meter, and also because you are actually inverting a system to provide you with 235 volt AC, or 230, 220, 230, 240, depending on what you're using. As for me, you can see my voltage right now for my inverter is 232, and over here it's 227, and here 229. So based on that, the inverter is trying to invert a 24-volt system to give you that much voltage. That would also consume some current as well in that process, and at the same time it's going to reserve some additional current that is going to use to, in case that whatever equipment that you have connected to the inverter that is drawing energy, because they will have intermediate spike in between as they go up. That is why you will not get uh, a stable amp coming out, or you're not going to get a stable. Look at it; it's going to be fluctuating. You can see. So that means that as, let's say you turn on your TV, as you switch the channel, or as the pixels of the channels of your TV changes, they consume. They request for some energy. You see, for some power, additional power. So in that case, you will get that kind of fluctuation, basically. So that is why. So basically, what I would say is this: always divide the voltage that you're consuming by your battery system. That is when you can determine how much current that will be coming out of your battery. Now, if you have a 12-volt system, it's going to be totally different, because you'll be pulling a lot of current to invert that to produce, to give you your power, your energy for your AC appliances. If you have a 48-volt system, it's going to be a bit lower. You will not be pulling that much current. I personally just prefer to go on a 24-volt system, because I think it's still kind of reasonable. I don't want to be combining four batteries just to make one battery array or battery bank. So that's just my own take for now. It's been a good day. As you can see, this is my automatic transfer switch. I would always explain this every time that I'm here, just giving some information about it. It's doing well right now. As you can see, this is blinking on the side. That means I am pulling from the inverter, and once this voltage goes to 24.2, automatically switches to the national grid. And also, last time I did share that they would normally advertise 11 kilowatts for 240 volts AC appliance, and 5.5 kilowatt for 110 voltage, for example, in America. But that's not the real capacity of this. You will receive this information, this leaflet, once you receive your package, once you purchase it. As you can see, it's telling you if you're using a 24-volt system, the load cannot exceed 600 watts. And if you're using a 24-volt system, it cannot exceed 1,200, that is 1.2. Let me just read what is on the screen here. That is 1,200 watts. And the way they reach that calculation is 24 volts times 50 amps. And for 48 volts, as you can see, you can go up IMO up to 2400 watts. So that is the real capacity with your battery. I'm hoping they will come up with higher one model for 24 volt that can go up to maybe 3,000 watts or 5,000 watts, so that I'm able um, to put more load on it. Now, having said that, I am currently pulling up to 1.4 kilowatt hour here. So 1.4 kilowatts, that's 1,400 watts that I'm pulling, which means I'm already exceeding the 1,200 watts that they said I shouldn't exceed. I'm currently exceeding it. I think where it's going to go bad is the voltage should go down and it goes over to the national grid. That's what I suspect. I've never tried that because I don't want to damage it. And you want to switch over back to the inverter and you have about 1.3 or 1.4 kilowatt as I have right now, it may damage it. That is what I suspect. But because the sun is up there, I'm generating a lot of current. I think I'm able to operate on it right now. I mean, I've been on it, since morning around 7 a.m. in the morning, and it's been doing well since then. I've not reduced the load. I've even added more to it. So, thank you guys for listening to me. If you have any questions, please you can put in the comment below. You can also subscribe to the channel because I'm going to be sharing a lot my data sheet for this month based on everything that I've recorded in terms of daily um, um, wattage consumption and daily amp hours and the total calculations and what I've done so far today. So I'm going to be, because I've been collecting this data since around October, November last year. So I'm going to be giving you my own breakdown if you want to go on solar. And I'm sure it's going to be really helpful for you. If you're already on solar, it's going to give you some more tips as to what you can achieve through days. When there's sun, it's beautiful. When there's no sun, you feel really frustrated. But um, I need this because I am consuming quite a lot. I've got a lot of servers on it right now, and yeah, because my bill is quite high. I would not suggest anybody who is getting any household that is spending around £30 or £45 monthly on electricity bills to go on solar. I would just say just keep on using the national grid because of the investment cost. But if you're spending around £100, £100 or anything above £100 on electricity bill, then this is something that may be worthwhile, that you may want to go for, that will help you to reduce your bill. But I would strongly recommend if you actually consuming or you're paying anything above £500 a month for electricity, or even anything above £300 a month, I would suggest that you should go for off-grid system or solar system. It's going to really help you to reduce um, your cost on electricity. You will need some space. I often prefer ground-mounted solar panels, but if you have enough space on your roof, please do go for it. Yeah, I'm using gel batteries. I've got 26 kilowatt hour gel batteries that I've combined together. Not all of them are from the same make. I have to because of the cost. I have to test them individually and then check their capacity just to make sure that they are, you know, they would work together and one is not going to be draining down the power. So I've actually exceeded the amount of minutes I want to spend on this video. Really sorry about that. Um, Thank you again for listening to me. Have a good day. Bye bye.
Hi guys, welcome to my data sheet for uh, April 2022 solar energy utilization analysis. So today is the 30th of April, and I just thought let me just share what I've gathered so far. We're going to ignore this part. Basically, what this is talking about is the fact that I have three arrays. As you can see, they are color coded. So this is one array. I measure the watt hour and the amp hour. There is another array. I measure the watt hour and the amp hour. And this is the third one. This blue part, this is where I have the blue watt meters, and I have an, another, or I have that blue watt meter connected to my MPPT chart controller that comes with its own watt meter. So I try to compare the data that is coming from the blue watt meter with the one that comes with the MPPT chart controller itself. So that's where this blue screen or blue column comes from. Just a feedback to the company that manufacture those watt meters basically. So what we're going to be dealing with will be the total watt hour. So you have got the daily entries, and the total for this day, which is on the 1st of April, is around 8 kilowatt hour that I generated on that day. And I also have a quick visibility with this chart here, so you can easily see exactly how I have generated solar energy all through the month. So if you look at it from top to bottom, so far this month I have generated 260,000 watt hour, 260,032.6 watt hour. That's what has been generated. Now, I have not used all of this, and we're just going to do a quick calculation for this so that you see exactly how what I've used out of this. Now, I've got usable, so this will give me daily usage of what I've used. So on this date, I generated 8,000 watts, but I've only used 5.6 kilowatt out of it. This also I generated like 8.4 kilowatt, but I used 6.1 that I've used inside the house out of it. And the same thing applies to every other, as you can see. So which means in total, just delete this one. So in total, as you can see, I've used 185.7 kilowatt hour out of 260 kilowatt hour. Now, um, so when I did the calculation, I noticed that on the average, I'm using around that 60 um, to 75% of the total energy produced from the solar panel. Let me just bring up this calculation just for the sense of accuracy here. So I would say I've used 260 kilowatt hour, and I've used 185.7 that I've used. So I just want to check the percentage of that I've used basically. So that's around 71.4 percent that I've used out of all the total energy generated from the solar panel, 260 kilowatt, but I've only used about 70% of it. Now, what happened to the rest of the energy? Well, um, let me bring up the calculator as well. Now, I try to keep track just to try to give an account of how the energy is being used or what is being used for. Now, my inverter on a standby, just to keep the inverter running, I would the inverter itself use 2.6 amps. Now, because I have a 24-volt system, I would multiply that by 24, and that gives me 62.4 watts that the inverter is using on a standby mode. Now, I would have this inverter turned on for roughly on average of 11 hours a day because I've had a lot of sun in this April. So I would say around 12. Let me just put it for 12. So times 12, that gives me 288 watt hour that I'm using in a day that the inverter itself is using. And I will multiply that by 30 days because we've got 30 days in April. and that gives me about roughly 8.6 kilowatt uh, that I've used this month. So that needs to be added to this 185.7. So that should give us isn't it? 8.6 plus 185.7. So basically, I've used 194.3 kilo that I can account for. Now, so if we minus this by the 260, we still see that we still have some energy loss here, about 65.7 kilowatt hour is lost. So where is this energy going? Where has it gone? The other thing that you would need to look into in trying to explain this is this. Now, your batteries, okay, let me put it this way. What you're doing is that you're converting electrical energy and you're saving it into your battery, which is a chemical. So you're converting electrical energy into chemical energy. Now, the chemical energy is now your battery. Now, the process of conversion, or let me put it this way again, it's not always 100%. Whatever you save in form of chemical energy, you don't get 100% out of it because it's a chemical energy, and it also depends on the temperature. So the manufacturer of your battery will tell you that the rating they have given the battery is based on the standard testing condition, which is the temperature compensation. So usually this will be around 25 degrees centigrade and down to minus 18, depending on the CCA rating or the CA rating that they have applied. So basically, you will notice that there is no way you can achieve that standard testing condition of 25 degrees at all time. So which means your battery hold the best charge when you reach that 25-degree centigrade. But you know UK weather is not always the best when it comes to the temperature, usually to be like around that 10 degrees or below that. So that's one of the reasons why you would not be able to get 100% out of your battery. And so that's the part where I would say most of the energy must have been wasted. And the other thing that I would normally look at is the conversion ratio, because you are converting a 24 volt system into a 240 volt AC, 24 volt DC to 240 AC. That requires a lot of energy as well. So some part of this energy, this 65.7, would have gone into that would have been wasted through that process of conversion. So these are the three criteria that I would normally look at. I look at the inversion of 24 volts to 240 volts. I look at the temperature level. These are the things that waste the energy. I also look at the fact that you're converting electrical energy, you're saving it into chemical energy. I will look at that. And fourthly, I will look at the fact that your inverter, so your inverter is consuming energy in order to maintain or to maintain its operation, basically. So um, that's just all about it. That's what I can explain. If you have any further suggestion, or if you have anything that you think that I've missed from my analysis, please do share with me. And yeah, if we can look into March, in March, let's go into March. I generated 163.4 kilowatt hour. I used 113.5, which is still around that 65 to 72%. And in February, total I generated 84.6. I used 53.1 in terms of AC usage. And let's go back to January. Now, in January, I have not installed the energy meter, so this is all I generated. December was the worst out of the entire year of 2021. So I generated 22.8. I would normally just look at it that, okay, I used like 70% of it. So you can do the calculation on your side if you want to. And this was in November. I did not have the energy meter then, and I got 47.5 kilowatt hour. So I will still approximate it to around that 70% that I used out of that. So basically, that's just it from me. If you have any question in regards to my data sheet or my data log, please put in the comment below and we'll get back to you. Thank you very much. Cheers. Bye.